In today's technology-driven world, data has become the pivot around which numerous companies revolve. It has become a matter of innate necessity for companies to harness the volumetric information that they ingest and subsequently garner those data values that are both usable and insightful for them. In this session, we will talk about the background story that led to the genesis of Power BI. We will discuss Power BI as a tool. We'll talk about different features of Power BI. After that, we will present a demo on how to install Power BI. After that, we will talk about transforming, shaping, and modeling data. Following which, we will talk about data visualization and finally conclude the session with a demo on how to generate Power BI reports. Before beginning the tutorial, let us take some time and meet Sam, Tom, and Daisy. Sam and Tom are just like you who want to learn Power BI, and Daisy is a Power BI expert who works in an MNC. Let's begin the tutorial then. Is there a background story that led to the genesis of Power BI? Well, certainly there is, and we are going to tell you that. There are 4 major factors that kind of inspired Microsoft to come up with Power BI. Need for BI, data sources, limitations of managed BI, and trends in BI. First comes the need for BI. Before BI, companies faced great difficulties while conducting their business operations and reporting, analyzing, and collaborating with each other to make the most out of their data sources. Data was getting ingested from multiple sources, including on-premise databases, cloud databases, SaaS providers, and other files. And companies were not able to process all of this information as a whole. This led to certain limitations. What are these limitations? There were various problems with regular BI that companies were vested into. These included time and budget constraints and failing to keep up with the evolving demands of their customers. Also, there was a lot of dependency on third-party vendors for report generation. In addition to that, there were certain trends in BI that were emerging, and Microsoft had to do something to find a solution for all those problems that were there beforehand and keep up with the trends. Companies had by now realized that hiring third-party vendors for analyzing data did not make much business sense. Therefore, they were in pursuit of certain tools or solutions that would empower them with self-service reporting. Also, there was a prevailing adoption of BI in the marketplace. So, did we find a solution? Well, we did. And this is where self-service BI supplanted traditional BI altogether. Self-service BI is basically an environment where companies do not depend on IT to generate reports. Sounds alluring, right? Well, it truly is. So, what are the advantages of self-service BI? The advantages are many. Apart from eliminating the use of complex programming skills for report generation, self-service BI allows users to share the reports that they have generated. But how can we implement self-service BI? Is there a particular tool or solution for doing this? Well, brace yourselves and say hello to Power BI. This highly advanced product from Microsoft is a set of tools that enables users to connect, visualize, and analyze data with greater efficiency and speed. Now, Sam has a question. What can we do with Power BI? You can do many things with Power BI, but basically Power BI enables users to transform data into visuals and share them with their colleagues, explore and analyze data from all sources, and scale across organizations with built-in governance and security. There are 3 different versions of Power BI: Power BI Desktop, Power BI Service, and Mobile Power BI. While Power BI Desktop is an on-premise application for Windows 10, Power BI Service is mostly developed as a cloud offering, and Mobile Power BI is a mobile app that allows users to access Power BI on their mobile devices. But why is Power BI this popular? Well, thank its components. And these components are meant to let users create and share business insights in a way that fits best to their business roles. There are 5 different components of Power BI. Power Query and Power Pivot are engines that help transform data. While Power Query fetches and cleans data, the processed data is loaded onto Power Pivot. Next comes Power View. This is a data visualization technology that lets users create interactive charts and maps and other visuals that bring data to life. Following them commence Power Map and Power Q&A. Power Map enables the processing of accurate geographic locations in datasets, and Power Q&A makes it possible for users to interact with reports with simple English language. Now, Sam wants to learn more about Power BI Desktop. Now that we have a basic understanding of Power BI, let us drill down deep into Power BI Desktop. Power BI Desktop combines Microsoft's Power Query engine with data modeling and visualization for enabling users to create interactive reports. There are 3 different views in Power BI Desktop, each of which serve a different purpose. First comes report view. In report view, users can add visualizations and additional report pages. They can also publish reports to the portal. In data view, data shaping can be performed using query editor tools. And thirdly comes relationship view. Here, relationships between datasets can be managed. What about Power BI service then? Tom is really curious. Well, as Power BI service works on cloud, businesses can use it to design intuitive dashboards which in turn can help control each facet of their business both effectively and efficiently. There are 6 aspects to Power BI service. First comes licensing. You can choose a Power BI account, either a free one or a Power BI Pro subscription account. Manage users who are a part of the Power BI network of your organization through tenant management. You can use datasets to import data from on-premise cloud databases, files and SaaS connectors. Also, scrape data from a web page into Power BI tables using datasets. Use role as security to restrict the data that a user can view in your network. Also, you can share packaged reports, dashboards, and datasets as contained packs with fellow users in Power BI. And interact with reports by asking questions using natural language queries, which is essentially the basis of the Power Q&A feature. Moving ahead, let us traverse through the key features of Power BI. First comes artificial intelligence. Azure Cognitive Services bring together a set of powerful and pre-trained models for intelligent applications. Hybrid deployment support provides built-in connectors that allow Power BI tools to connect with different data sources from Microsoft, Salesforce, and other vendors. Natural query language enables users to interact with reports and ask for specific data. Microsoft has also integrated Cortana with Power BI to enable conversational BI. Users are flexible to customize business reports as per their business requirements. APIs for integration are available to provide programmatic access to dashboard resources such as datasets, tables, and rows. Through self-service data prep, data flows can be used to ingest, cleanse, transform, integrate, enrich, and schematize data from a large array of transactional and observational sources. With modeling view, users can break out complex models by subject area into separate diagrams. Now, I'll show you how to install Power BI on your Windows 10 desktop. For that, all you need to do is open a browser, and I'm using Google Chrome. In Google Chrome, what you need to do is open the Microsoft Power BI website. So I type Microsoft Power BI, click the first link over here, and this page comes up. And here you will always find an option, Start for free. What this means is that you can download the Power BI desktop for free. And then if you need a subscription account, you can continue it further. So I will start for free, and now I will find this pop-up, and now this is another option that I get here, download for free. So click over here, and now this pop-up menu appears, and you have two options over here. So, and as we know that Power BI is a product from Microsoft, you can directly download it from the Microsoft Store. So open Microsoft Store. By doing this, the product will download automatically and install on its own. And once that is done, you will see this. This product is installed and you can launch it directly from here. As I had already installed my product, I was not going through all that process. So I will launch the product directly. Now Power BI desktop will open. Now once it's open, a menu will appear and you will have to fill in your credentials. After that, click on sign in, and here you will have to use your professional account. I'll be using the account of a friend of mine. Okay, that was a mistake. Yeah. So sign in. Now I'll have to enter the password. Unfortunately, I have a password. So we have signed into Power BI desktop, and this is how Power BI desktop looks like. As we had discussed, there are three different views in Power BI desktop: report view, data view, and model view. In addition to that, you have three different menus. In the home menu, you have these options. You have get data, enter data, edit queries, new page, new visual, buttons, and all of that. So what you can do is, before starting the process of creating a report in Power BI desktop, you need to import data into it first. And for doing that, you need to click on get data. Once you click on get data, you will find these many options. Now what does this mean? This means that Power BI can take in data from a huge number of sources. It doesn't have to be a particular Excel file, it can be anything. As you can see, you can click on more over here. Now a list will appear. Now these are the different sources which are compatible with Microsoft Power BI desktop. So you can take it directly from files, Excel, CSV, XML, JSON, PDF, anything. You can take it from directly databases, all these databases are fine. You can directly take in Power BI files which have a .pbix extension. You can take it from Azure, other online sources, and other files that include R script, Python, ODBC, Spark. I mean, any kind of data can be ingested over here, and this will work absolutely fine. Now, this is the beauty of Power BI Desktop. Or you can click on enter data and enter your data manually. You will find this option column. You can input the column and then enter values as per as your requirement. You can simply edit it and then load it. You also have edit queries option. Here you can, once you have created a table, you can edit queries and you can use queries to extract specific information from that table. Or you can click over here from marketplace. You will find these options. These are different visualizations. You can take it directly from the Microsoft website. It's absolutely free to download, or from my organization. Because we don't use Power BI as of now, we don't have any custom visuals. You can use custom visuals, and under my organization, you simply have to click it and then extract the visual directly. You can also switch your themes over here. And after that, now I will give you an overview of all the views that we have. First comes report view. Now this is where actually the report is created. In report view, you have two specific panes over here, the visualization pane and the fields pane. In visualization pane, you find these many visualization options. Once you enter a data set, you can visualize it with these many options. You have different things: stacked bar chart, column chart, clustered bar chart, clustered column chart, 100% stacked bar chart. As per your requirement, you have many other things and you can use any of it. You also have line and star column chart when you have multiple parameters in your table, and if you want to show a graph of multiple things, you can use all of this. You can also use donut charts, pie chart, scatter chart, and you don't have to worry. I will tell you exactly how to use these things in our next demo. You can also take data directly from R script visuals and Python visual. You can create your reports in these visuals also. All these options are available to you, and all you need to do, click on a visual, and once you have data in it, all your parameters will appear over here in this fields pane, and you can directly select a parameter and drag it over the axis on which you want to project it. There will be two axes, X and Y, and you can put it directly over here. And there are other options also. You can add data fields over here, add data values over here, and these are the filters if you want to apply. Also, in addition, we have these options, and all this will be active when we enter some data set. That is the only reason why this is not active right now, but I will give you an overview. You have the title thing over here. You can enter a title, you can customize your background, the lock aspect, general things. You can give a border, visual header, and all those things. And analytics is not available for this visual as we have not entered any data. Once that is done, next comes data view. Here you can edit your data. You can manage it with query editing tools. Edit your queries, and once you have parameters in your data, you can manage those parameters directly from here. And then we have this modeling view. What you can do in the modeling view is that, suppose you have a big report and you have to break it down to make it more understandable, or break down into modules. So what you can do, you can simply enter the data over here and break it down. I will show you how to do that. So this is how the Power BI desktop basically looks like. In our next demo, I will generate a report and tell you how exactly can we work in Microsoft Power BI desktop. Now that we have installed Power BI, let us understand how datasets and data types work. The data that you import from other sources needs to be typed correctly in the first place. Plus, you might also have to change the data types as different sources may have different data types. Now a major question arises. Where is this data stored? In Power BI, data is mostly stored in fact tables and dimension tables. A fact table holds the data to be analyzed, and a dimension table stores data about the ways in which the data in the fact table can be analyzed. Now it is really important to note that these tables are connected and work in sync with each other. Now when we talk about tables, it is a sure thing that there will be data relationships, right? How can we manage them? Now don't we think before managing them, it is necessary to create them in the first place? So if there are no null values and duplicate rows in those facts and dimension tables, you can create data relationships. And there are two ways to do that in Power BI. Either you can do it manually, or you can use Power BI's inherent auto detect feature. What happens in the auto detect feature is that Power BI traverses through your data directly and finds potential data relationships and creates them on its own. Now let's see how data relationships can be managed. Data relationships can be managed with primary and foreign keys. What are primary keys then? A primary key is a special relational database table column which is specifically designated to uniquely identify all table records. But a foreign key is defined in the second table but refers to the primary key in the first table. And the relationship between these two keys is the stronghold of how tables are connected. For managing data relationships even better, Power BI equips users with cross-filtering. The cross-filter direction of relationships in datasets affects how Power BI treats the tables in visualizations and reports. There are two types, bidirectional and single directional. Bidirectional cross-filtering allows modelers to determine how they want filters to flow for data using relationships between tables, and single directional cross-filtering will filter one table based on another table. Sam is curious if he needs to shape and transform data before using it in Power BI. Well, if required, he must do it. And he can do it using the Power BI query editor. Here, users can load data from a wide number of sources and apply transformation on them directly. They have 4 options: Home, Transform, Add Column, and View. And when applied in the right order, these options can help transform data in a really quick manner. Let's move on then. What is shaping data? It is the process of transforming data so that it becomes best for your reports. This can be done implicitly in Power BI. The most common techniques of shaping data are removing columns and rows, renaming them, modifying data types, adding columns and indexes, and applying a sort order. Now Tom wants to know, why do we need to transform data? If data is not structurally appropriate, we might have to transform it. And this can be done using the query editor. In addition, the table group offers functions to quickly transform data. So what are these functions? These are group by, count rows, split column, use first row as headers, any column, data type, transpose, fill, rename columns, reverse rows, move, and replace values and errors. So using these functions, you can directly transform data, and these being library functions, you don't need any extension for using them. Now a question arises, when a data is transformed, how do we merge it? There are 2 ways to do this. First is merging columns. 2 tables must have a joining column where values will match, and when values match, users can easily join both those tables. And the second is appending rows. Take rows from one or more table and add them to the first table, and both the tables will be connected together. Now that we understand this about tables, let us move on and understand what DAX queries really mean. So what are these? DAX is basically a formula language which is specifically designed to work with relational data. There are many applications of DAX. Basically, they are used in expressions to calculate and return values, help perform complex calculations, and draw specific insights from data. Also, data can be manipulated in Power BI using calculated tables and calculated columns. What are these? In calculated tables, one formula is created using a DAX query, and that formula automatically adjusts each value in each row. Similarly, calculated tables are created in the same manner, but they are useful for intermediate calculations and specific data which users want included in their data models. And using all these features, intuitive business reports can be generated really quickly. Now Sam wants to create some Power BI reports. Well, we will show that in the upcoming demo, but before that, he must know the basic steps that lead to creating reports. First comes page layout and formatting. Report pages can be customized, and page name, page size, page background, and page view can be modified as per requirement. Also, charts can be created, and as we had demonstrated on the last demo, there are several charts that are implicitly available in Power BI. These include bar and column charts, line and area charts, line and column, scatter and bubble, pie and donut, table and matrix, tree maps, R visuals, and other charts. What's more surprising is that geographic data can also be included, and this can be done through map charts. Bing Maps is integrated with Power BI to ensure that users do not need longitudinal and latitudinal coordinates to include geographic data in their datasets while creating reports. And if everything goes as planned, you will successfully generate an insightful report on your business data. Now I will show you how to generate a Power BI report. For that, I need to open Power BI desktop first. So I will open Power BI desktop, and you can see this is my Power BI desktop and it is open now. What I need to do in the first place is that I need to import my data source, because without data we cannot create any report. And for that, I need to click on Get Data. This is the easiest way to import your data, and I need to select the file format. And because my file or dataset which I'm going to use to show you this is in Excel format, I will simply click over Excel and connect. Once you do that, you will find this browse menu or browse option, whatever you want to say. And from over there, you have to browse and select your file. I don't need to browse it because it's right here. So I will simply click on it and open. Once I do that, I find these options. Over here, I can see the number of sheets that I have in that Excel file. And I have only one sheet, so it's kind of mentioned over here. Now I need to select this. However, you can select as many sheets as you want if there are multiple sheets. So once I select this, I get a preview of that sheet with parameters and values. So this is basically how my data looks like. I have fuel economy, cylinder, display, horsepower, rear axle ratio, then I have weight, Q-sec, number of forward gears and carburetors. So what does this basically mean? So this is kind of the internal parameters in a car. So I'm going to make an actionable dashboard or a report using which you will be able to understand this data more clearly. So for now, I have selected this and I will click on load. Now I can say that my data is loaded over here. And how can I say that? I can say that because in this field section, I can see my sheet 1 over here, and under that these are my parameters. So using these parameters, I can create graphs and visualize them. And how can we do that? For doing that, or for creating a graph or a visualization in the first place, I have to select a visualization out of these options. Suppose I want to create a column chart. So I'll simply click on column chart. As you can see, this visualization opens, and when this opens, I will simply expand it to make sure that this is clearly visible to you. Now that this is open, I will go on and concentrate on my parameters. What I mean to say is that I need to select the parameters using which I will create the graph. Before doing that, I want you to see these two things. So this is the fields pane and this is the format pane. In the fields pane, you have different options: axis, legend, value, tooltips, then you have filters and drill through. So what you need to do here is that you have to take a parameter from here and drop it over here. Basically, this axis represents x-axis, value represents y-axis. So this is basically an area using which you can control your parameters. So we will work on that. Suppose I want to see a graph between, let's say weight and number of forward gears. So I will take number of forward gears and drop it over here. You see this add data fields here, right? I simply drop it on top of that. So that will be loaded. And the next thing I need to do is I will take this weight and drop over here. Add data fields here under value. I will drop it over there. So instantaneously, you can see that a graph is generated. Now, what does this graph mean? What basically means is that the number of gears that I have, suppose there are 3 gears in my car or 4 or 5 forward gears, accordingly the weight is getting changed. As you can see, if I click over here, this gets selected and this gets deselected. So what to do now? Suppose I am not happy with the title of my visualization. What I can do is that I can go to the format pane, and in my format pane I can click titles, and in place of weight by number of forward gears, I can simply write graph 1. This is just to show you. So I write graph 1. If I want, I can change the font color. I'll change it to this color. I don't know what we call this, but okay. I'll change it to this. But still my alignment is over here, so I will make it center aligned. But still it is not clearly visible. So I'll increase the text size. As you can see, now it is kind of visible. I will switch on or enable the borders. Okay. And on top of that, I will make sure that data labels are on. So what happens with data labels is that you get instantaneous data. I mean, look at the graph and you can judge. If you don't want this, you can simply move your mouse cursor over here and you will find data. So on taking my mouse pointer over here, what I can see is that number of forward gears is 3 and weight is 58.39. Over here, number of forward gears is 4, weight is 31.40, and that is how the graph is working. But now, if I want to see this graph but as a stacked bar, so what I need to do is that I will simply click on this stacked bar over here and I can see this as a bar. Or if I want this as a 100% stacked bar, so I'll click that and you can see the difference. But 100% doesn't work because we only have 2 parameters. Or suppose I need a line chart. Click on the line chart and I can see the differences. For 3 it is 58.39, for 4 it is 31.40, for 5 it is 13.16. So that is how it works. Now suppose I want to see this as an area chart. I'll click that and it happens. So you can customize your visualizations the way you want. But these were only for 2 parameters. Now suppose I want to add more parameters over here. So what I will do is I will select the right option from here. Let's say I will select line and stack column chart. So what will happen over here is that in this fields pane, I will get one more option with the name line values. Now I can add one more parameter over here. Now suppose I want to see my fuel economy. So what I need to do is that take this fuel economy and drop it over here. And you can see the fuel economy appears as a graph. It's quite clear, right? See, just because there is no value of weight over here, we can see only number of forward gears and fuel economy. But if I move my cursor over here, I can kind of see everything. Now, suppose I want to add one more parameter over here. Suppose I want to add number of cylinders with weight. So what I need to do is that I will take cylinders and put it over here under this weight. Added. So as you can see, my graph changed. So here I can see my cylinder value. Here I can see my gear to weight ratio, and here I can see my fuel economy. Now I want to create one more graph. So this is done. I can minimize it, take this to a corner, and now suppose I need to add an API. So I'll click that key performance indicator. So what I will do is that once I select that, I will simply select fuel economy and drag it on indicator. I'll take horsepower and drag it to this axis. Now when I added horsepower to trend axis, you can see I see a value over here. And what does that mean? See, there are different filters over here also. If I want, I can apply filters is greater than, then apply filter. But there are not much parameters over here, so there is no point of doing that. So what this basically does is that it kind of adds value. You see your sum over here. If I want average, I'll click on average. You see a graph, it is changing. Suppose I want count is 1. Suppose now I want standard deviation. So what this necessarily means is that this value or the indicator is the fuel economy, and the trend axis that is going in the background, that actually means the horsepower. And as you can see, is continuously changing for these different aspects. So count distinct, it's 1, and this also changes accordingly. Suppose I need minimum 15. So this is the fuel economy and this is changing in the background, the horsepower. Now suppose I need to create a donut chart or a pie chart. Let's create a pie chart. So I change that. For pie charts, as you can see different options over here. If I select this, all others are deselected. So let's maximize this to make it easy to understand for you. As you can see in this pie chart, different values appear. So here the horsepower is 65, minimum of fuel economy is 33.90. Similarly, it changes. So this is again a ring chart or a donut chart as we say. Again, this means the same. So this is how you can work around Power BI desktop. You can change your values, or if I want, I can add one more horsepower over here in this values and I will see this. So this basically shows horsepower and this shows the sum of it. I want average, so I click on average and I can see the values changing. But I'll maximize that. See. Now, suppose I want standard deviation. It is changing. I'll switch on my title. Yeah, and now I'll give a title text. Let's say horsepower indicator. Fine. As you can see, my title appears over here. I will change its alignment and increase the size. So now I want to see my median. So I click on median and my median changes. So this is how Power BI generally acts. Now I can do one more thing. I can simply select any of these values, drag it and drop it in this canvas directly. By doing that, just because this is a single value, a column chart is created and Power BI does it on its own, because Power BI has the ability to kind of understand the data that we are ingesting in, and it creates visualizations on its own. Now let's see, I take horsepower and put it on top of here. So a new graph is created. So this is like horsepower versus display. But now I'm not happy with this and I want to change this. So I simply select this graph, click this gauge. Now you can see it changes. So these are many ways how to create visualizations. This is how you can do it. So we created this graph, we created this indicator, we have this KPI. In this KPI you can see all these different values. We have this indicator. So now what we can do is that, suppose I am done with this and this is the report that I wanted to generate. So now I have to publish this. But before that I need to save it first. So I'll save as report 1, and this report 1 will have an extension of PBIX. That means it's a Power BI file, and I will save it in my desktop. So save. So this is saved. So what this means is that I can take that file and click on any Windows 10 operating system or any desktop which has Windows 10, and if it has Power BI, then this will open directly. On top of that, I can click on publish. By doing that, I will publish this report to the web. See, I'll show you. I'll click on publish. It will be taken to my workspace. So I will select my workspace. Now this report 1 is being published to Power BI. See, now it is published. So I can open report1.pbix in Power BI. What this means is that once I click on this, I will open Power BI service. As you see, we open Power BI service over here. So I'll sign in. I will use the same account that I was using. I'll enter the password and sign in. So this is my Power BI service, Power BI cloud service, and this is not free actually, but for first 60 days you can use it for free. So as you can see over here, I have several options. I can see shared with me. No one has shared any contact in this account, so I can't see anything. I can click over my workspace, and over here I will find under reports report 1. I click on report 1 and I find my report. You can see this report, right? And now this is on the web. So for sharing this, I can either share it with someone by clicking on this option, or copy this link and send this link to the person whom I want to share this. And by simply accessing this on any browser, they can open this report directly. So in this portion, what we can do is that we can pin live page. So in pin live page, I will click this. I will create a new dashboard under the name, let's say Roshan Power BI demo. Then I pin it live. Now it is pinned to dashboard. So either you can create a phone view or go to dashboard. Or I can do one thing, I can simply, or if I want to add more visuals over there, I can simply pin this visual, existing dashboard, Roshan Power BI demo, pin. And once I pin those things, I can find my dashboards over here in the left side. Under this dashboard, I have this Roshan Power BI demo. So I click over here and I find my options. I had this display that I had pinned later, and I had this whole report in the first place. So if you remember, we had this Power Q&A feature. So you can simply ask questions about your data directly over here using simple English and you will get answers. So suppose I will write total weight, and I find the total weight is 102.95. Suppose I want to see display, and I find it here. All I need to do is that, suppose I want display minus total weight. Can't display the visual, okay, but that is how it basically works. Over here you can find your usage metrics, and you can simply click over here and open it. That's how it works. So this is basically all about Power BI. And finally, if you want to share this, simply click over share this dashboard, enter an email address with whom you want to share. Suppose I want to share this with roshan.intellipart@gmail.com. See, now you will find this message. One or more email addresses with the following domains are outside your organization, gmail.com. Just because my account was created by the extension intellipart.com, I can't use gmail.com. I have to share this with someone who has an extension gmail.com. So I will write bala at intellipart.com and it works. So I can share this with people who work in my organization. That's all. On top of that, you can provide access also. You can, once they are your partners or you are connected to them in Power BI, you can provide your colleagues access over here also. So this is pretty much it about how Power BI works.
Now we have created our first basic dashboard with Power BI. We have good range of visualizations here. So now let's publish this to the cloud Power BI service. So we are still in Power BI desktop. Let's publish this to Power BI service. So for that we need to have an account. So I already have an account. I have logged in. So when you launch Power BI desktop, it will ask you if you have an account, login. So I had an account, so I logged in. So that's why you can see my name here. So now I want to publish this to Power BI service. I simply click on this icon. So clicking on this icon will take that. So I already have some file, a data set named Lands Transportation Corp there on the cloud service. So let's replace that. But this file, this DXP, this analysis file will be new. Okay, got it. So now it published to Power BI. So if you want to open, you can click on this link and you can go there, or you can log into your cloud account and you can see your analytics there. So what I'll do, I'll click it here. Okay, let's not do this with IE. Okay, first let it get open there. Yeah, so this is a link. Copy this link, get out of here. Let's close the data file because we don't need it now. Okay, so it'll ask for the login. So I have this Microsoft account. It's asking for mobile authentication. Here you go. This is Power BI Cloud Service. This is a dashboard that I just created. Okay, so this is the actionable dashboard. You click on data, the data get filtered. So you see this is the data. So the filter works on all levels of data. So if you want to select multiple bars, you can control and click. You can press control and select multiple bars of data. Yeah, so this is the actionable dashboard now we have in Power BI Cloud Service. So this is how the cloud service looks like. So when you deploy a report, that will come here in this section, reports, in this section. So now from here you can compose a master dashboard. What you can do, you can select the icons, select total revenue, you click on them. So it will ask you to create a new dashboard or to any other existing dashboard. I'll select new dashboard. I'll name it as finance dashboard and just pin it. Okay, so now you see this is a new dashboard got created here, and we can see that as a tile here. See that visualization is a tile here. Now if I click on this tile, it will take you back to that report, the dashboard, the underlying report. We can pin multiple visualizations there. Yeah, airlines dashboard. Yeah, pin it. I'll pin one more KPI, and then this map. Let's get check out dashboard. This is how this dashboard looks. You can arrange them conveniently. Just drag and drop. So you don't develop any visualizations here. So this is pinning from already existing dashboards. This acts as a master dashboard. If you click on that, so it gives you an aggregated brief overview of the data. We can pin visualizations from multiple dashboards into this canvas. Okay, let's leave it there. So the natural language query option that I showed you is not available at a report level, but it is at a master dashboard level. So now when we have pinned something here, now we see here, ask a question about your data. I can comfortably ask a question like this: total revenue. So this is my total revenue. You see there, that's my total revenue. Say in August, I can just select a month, particular month. It changed. See, total revenue this is in August. You saw the variance. I say just total variance. This is my total revenue in August. This is the total revenue in August. Okay. Say revenue by source city. So let's select here city. You see, I will see what top 5 revenue. I have no visualizations for all this. See, top 5 revenue by source city. Origin state or origin city. Okay, this would generally come up in descending order of this. I can change a chart type also here as line chart. I can see it as a line chart or a bar chart. I can set. It's just not that. Once you start once you uh, finish creating a visualization, you can actually do some more enhancements. You can go at a visualization fields level. If you don't want this as a bar, you want this as a pie chart, yeah, you can convert that into a pie. And you want to change color schemes, yeah, you can change. You can do further modifications, and then straight away pin that visualization to your dashboard. That's it. Now get back to the dashboard. You have that here. You have that sweet pie here. So just created by human computer interaction. Yeah, it's not that tough. Okay, arranging this. Okay, there you go. Fine. So now, so this is master dashboard. So here you can place tiles. You can now, when you click them, you'll get back to the original reports. You can run natural language queries. Yeah, you can compose. You can create ad hoc reports like that. So that's one ad hoc report that I created, that pie there. Okay. So you can start sharing your application from here. You can go. You can check out the notifications that you have. Select a particular visualization. And so this menu is getting changed every now and then. As I told you, right, this is highly evolving tool right now. There are a lot of enhancements, improvements that are being made to this application. Where is this option? Okay, so we have no notifications. So I think so just that share option is disabled here. So we can add accounts here. So if you have any Power BI subscription users, you can add them. You can add the users to this report here. I'll show that shortly. So now here the another feature is, the another way in which you can publish this report is by creating it as an embedded copy. So when you click on this publish to web, so it will create a copy, embed copy. So now you see this iframe code here. Yeah, you close this. Now anybody with a link, with this link, can access, can analyze, can view our analytics. So this can be freely embedded into any application. So this is Power BI embedded. You see, so this is a page. You don't get all that features here, the settings, filters, dashboard options. Yeah, at the moment there is no natural language query support also in this embedded copy. But still this is an actionable dashboard. You can still click this, view data, check everything that you are interested in. So this is possible. So this is possible with Power BI embedded. This is the other way. So this is an easy integration into other applications, your existing reporting applications, quickly integratable. So yeah, so just created that link there. Okay, so we have two data sets, workbooks. We have multiple options here. We will keep exploring the options as and then we progress in our course. So for now, so that's an end-to-end flow. So we created an application in the desktop, Power BI desktop. We created a dashboard. We published that to the net, Power BI cloud service. We got that here under report section. We pinned some visualizations to the dashboard. We created a new dashboard and we pinned. Actually, we can pin the entire page. This entire page we can pin into a dashboard. Okay, and there we used some natural query languages, and we also show how to publish it to the internet. Okay, yeah, you see, here we have this share option. Okay, we have share option at a dashboard level. This is what I wanted to show you. So if you click on this, it will give you a panel here. So anybody with cloud subscription, that email address, if you add that here, yeah, you can grant access. So a mail will be sent to them, and once they log in their workspace they will see our reports. So that's how this cloud, so there is no local setup, there is no local infrastructure for Power BI reports. So everything is on cloud. The only thing you can set up locally is a gateway, Power BI gateway, to talk to on-premise databases. Hi, so here we have the basic dashboard built and published to cloud service. So we will go explore further in the next assignment on how to perform calculations. Here we haven't done any calculations. We got the data as is and then we represented with some set of visualizations and we published. But this won't be the case in real-time situation. So you often run into need of writing a custom formula or a expression or a calculation to represent data in your visualizations, right? So we have options in Power BI for doing that. So the next assignment is targeting on the data calculations using DAX expression. So DAX stands for data analysis expression. So I'll give an introduction on the DAX and then we'll write some couple of formulas on the data, existing data, and create visualizations on top of them. So we'll discuss more of DAX in upcoming assignments. So for this assignment we'll target on introduction to DAX. And also we'll get two new data sets into the analysis. We already have TRIPS data that is coming from the Excel source. Now I'll import two more data sets into this Power BI desktop. So the data sets would be coming from Open Data Feed. Our data is Open Data Feed. So this is a data feed that is hosted on web. So it's like a complete data warehouse being hosted on web, and we can get data feeds that we are interested in. Okay, so the feeds that would match my data are categories. So in this navigator I can simply see the preview and select the ones that I need. Yeah, shippers. Okay, load. So that will also embed directly into my analytics file. You can see these two tables, now they are added here. Go to this panel, I can see those two tables here. Okay, so the good thing with Power BI desktop is the moment you add any new tables into the analysis, if there are any relations between the two tables, they are automatically created like this here. You see, I have trips data, categories and shipper, because they already have keys in my data, shipper key and category key, so they are matched. Go and check out the definition of this relation. You can see here trips category ID, categories category ID. Yeah, same is the case with the shippers. So these relations are auto created in Power BI. So now we'll get back to the trips database. Okay, so this is the transactional data I have here. If you actually observe here, so here there is no option to write any expression for this visualizations. You see, we can only drag and drop fields here. We can drag, we can drop, we can configure those fields, we can format, we can set reference lines, but we can't actually write any expressions at visualization level. All the expression writing should take place at a table level like this here, a new measure or a new column at the back end. So entire expression writing in Power BI is divided into two forms. Either you do a row level calculation, that is row context, or a set level calculation, which is set context. Row level calculation is something like creating a column out of some existing column. Okay, subtracting these two values and creating a new column. So that is you do at row level. Okay, so that is row context, which is new column. And what is set context? Set context is new measure, creating an aggregated value. Maybe I want to find out the maximum of this ship days or miles, total miles or ship days. Yeah, so that is an aggregated value which is at a set level. So that is set context. So for such needs we'll create a measure. So we have to decide first what we want to create. We want to create a measure or we want to create a column. For both we will use DAX. Okay, so DAX is very simple. We don't need to worry about that. If you are at least some aware of Excel formula writing, you can easily pick on that. Is because DAX is completely Excel formula based. But it is more than that. Yeah, but still for now we can consider it like that. Okay, now I'll create a column. In this assignment I'll only focus on row context. I will do row level operations, only row level operations. So I'll create a new column. So here I have ship date and then delivery date. Ship date is when it was started for shipping and delivery date is when it was delivered. So this is a target. So it's saying that it should not take beyond this. So this is minimum expectation set. If you see, this is January 4th, it started for shipping, 2 days, so it should arrive for January 6th, which is the case here. So this is on time delivery. Okay, but there could be some variance. So here June 7 and 8. So this is 1 day early because 7 plus 2 is 9. Ideally should be delivered by 9, but there is an early delivery. Okay, yeah, there will be cases like this, not in India. Okay, so now go and create new column, and in this I'll write a formula. Delivery days equal to ship date minus, okay, I'll do it the other way, actually should be done the other way, delivery date minus ship date. Okay, we have now a new column created here, but now right now this is in date format, but generally this expression will return a whole number because that context is not set, data type is not set. So select the column, go to modeling, and you can see data type. Why I am not seeing data type highlighted? Ship days, this should get highlighted generally. Okay, okay, there is some issue here. Delivery date, yeah, delivery date, sorry, not delivery date minus delivery date, delivery date minus ship date. Yeah, so that's what I did here. So I got this date column. Fine. Okay, now you can see here the data type and format. It is assuming that it is a date column and it is giving you this format option, date format option. Okay, but that's not the case. So let's change the data type. Change it to whole number. Yeah. Okay. Now you should be seeing it in actual form. Okay, fine. So this is delivery days. Okay. Uh, Fine, all values seems to be okay. See here, huge negative values. Okay, this is because these are the shipments that are never delivered. Various reasons. Uh, Maybe address was wrong, people were not there at home. Okay, met with an accident. I don't know, or not ready. Goods were not ready for shipping. Various reasons the delivery are undelivered, so the date is null. So this is not correct. So to show this as a big number here, so let's do some more calculation here. We'll do a conditional statement here. If is blank, delivery date, then put 0, else do a subtraction. So if it is undelivered, there is no point in calculating the difference. Let's take it as just 0. Okay, so all these values will change. Okay, there you see. Okay, fine. So now I got delivery days. I'll go to the next level and I'll calculate delivery status. Add one more column, new column. Delivery status. So this I will calculate based on the days. So here, so I have delivery days and then ship days, right? So if both are matching, then yeah, correct. So that is on time delivered. Let's see the combinations. If delivery days is equal to ship days, then it is on time. Another if statement, if delivery days is less than ship days, then it is early delivery. If it is not on time, if it is not early, then the last option you don't have to check. We can directly write late. Late delivery. Okay. So we got on time, early and late deliveries. We have missed out one more. So what about undelivered? It will be delivery days would be 0, so we have to handle that as well. So we'll do what? We'll put one more if clause on top of this nested if statement. If the same thing we did for delivery days, if delivery date is blank, then undelivered. Else do all this. If is blank, undelivered. Else okay, if okay, we haven't closed bracket here. Okay, now I got this new calculated column which will tell me the delivery status in a readable way, readable format. I see we can write this expression in many ways. I can actually directly do on dates, like if ship date is equal to, so generally ship date will not be equal to delivery date. So if you add ship days to ship date plus ship days, if it is equal to delivery date, then it is on time. If ship date and plus days is less than delivery date, then it is early delivery. Yeah, so like that I can write a calculation. So I can write calculation in many ways. Okay, so here I have demonstrated a way. So I first calculated delivery days, because in delivery days also I can use in some way, and then I derived one more column, delivery status. So these are row level operations. So that way we create a new column, and these are called row context. Okay, so here we go, we have a column here. So now let's get back to the report panel. Create a new page, name it as delivery analysis. Now get that delivery status, the column that we just created. See, now we have just verifying whether we got it correct or not. Then trip ID. Yeah, so yeah, total 2k trips, and this is a split. Yes, this came out correct. We have early, late, on time and undelivered. Delete this. Now we'll start building the analytics. Do Control Z, switch this into a pie chart. So this is what I got now: on time, late, early, and yeah. So we'll change colors a bit. No. Yeah. So if colors, can convey, so early means good, right? So yeah, we'll put some contrasting colors. Late, undelivered, represent it in a different color. Early, yeah, some good shade. Okay, so fine. So we got this here. On-time deliveries, late, and we can see that late sector is relatively small compared to the entire stack. Yeah, you can put stacked percentage bar chart like this, and you can analyze data by trip ID. So you can see here. So if you take the on-time deliveries compared to on-time deliveries, late or nothing, so just the 3%. Yeah. Okay. So now I will go and convert this into a pie chart, and in the pie I'll put some more fields, some more categories, like uh, after finding out that undelivered items are more compared to late deliveries, I want to further analyze where the problem is. So I will provide some more attributes here. So on the legend I will drag and drop company name. So now this is drillable to the next level. So I go and click. So now I can see by company. So this is now, right now it's giving only volume, how many trips were made by each company. So these are the vendors for my company. So I have tie-ups with them, they do the shipping for me. Okay, so now I can see that yeah, United Packages have more shipmates, getting more business from me. Okay, so the other way is enable this mode, drill mode, and now if you click on undelivered, so it will take you to the data related to that particular undelivered packages. So in undelivered, you can see that everyone is contributing equally, 25%, 25%, 50%. This is 50% because we already saw that we have more shippings here for United Packages. You go late and check out. So late, you can clearly see the difference. Only United Packers and Federal Shipping. So the third player is nowhere seen here. So who is the third player? Speedy Express. So there are no late deliveries from Speedy Express. You see, you click on late deliveries. Yeah, so we can see what good they are doing, but there are no late deliveries, and we can replicate that business model in other segment or sectors. Just not that, we can go further. After we got delivery, we can actually go and look out and check by state. Maybe somebody is doing good in some state and not in other state. We want to check out and replicate those practices. So you go check Federal is doing well. Okay, again they are doing well in Illinois IL compared to any other state, and Michigan. Yeah, so we can see like that. So this drill option we have for every visualization. We have two kinds of drill. At a time you drill down to the next levels like this. drill down, drill up, or you can enable this and drill by slice, the actual slicing. So you see this option, this will at a time will put all the data at once here, late, speedy, express, by state, like that. So it will give everything, merge and show it on single canvas. Okay, so drilling by merging, this option, this is newly added, good option. Okay, so we can do that as well. If you do this, it will just, you will not be able to relate from which slice we got this. So if we do this, we can relate actually. So undelivered, federal shipping, on time United, on time speed, on time federal. You go further, again on time United. So you see the hover message, on time United Packers, Ohio. So that is a state. We got all three on a single slice. This is another kind of drill down. We have totally three kinds of drill down. Plain drill down, go level by level. Yeah. Split for every category. Then go by hierarchical drill down. So this is hierarchical drill down. Or selected drill down. You select a particular size and drill only that particular focused area, interested area. So we have three kinds of drill downs. Okay, now let's put one more visualization here, so which would be stack bar. So in stack bar, what I'll do, I'll bring categories, category name, and then total miles versus loaded miles, variation between total miles okay. We'll switch this to side by side stack. I can now see that I can see here that in general total miles will be more. So the difference between total miles and loaded miles will give you dead miles, empty miles. So the concept here is, so total miles will include the miles that incurred in sending our truck to the pickup place, and once the truck the delivery is done, again when it comes back empty to our warehouse. So all that miles is included in total miles. Loaded miles are the miles only for which the truck was actually carrying the load. So the difference between the loaded miles and or the summation of loaded miles and empty miles will give you total miles. So we should, yeah, I think I already said this earlier. So now I'll put a reference line on this. I select the visualization, so go reference lines. We can add a bunch of reference lines. So these are analytical lines, so these are available for few visualizations, mainly for bar visualizations. So you go and select an average line. So I'll put an average line by total miles. Yeah, so you see, so these two are almost making the average, they are meeting the average of total miles compared to that. So they're doing good in these areas. Dairy products, grains and poultry, we are doing good. Okay, so yeah, we can add reference like this. We can switch to a full mode like this. Every visualization has this feature. You can always switch to a full mode, and when you right click, select something and right click, you can see data. If you click see data, it will give you the data of the entire visualization, and if you click C records will give you the underlying data records. So this is unaggregated data. So this is transactional view. This is transactional view. So same options will get here also. See data. So this is aggregated data which is constituting this visualization. Back to the normal mode and right click on the visualization and see records will give you the transactional view. Transactional view. So if you see actually, so go right click and say beverages, total miles, see records. This data would be actually related to, okay, now go early, drill down, show next level, all that we have. Okay, so because this data set, I want to show you. This is not the entire data set. So this is the data set which is constituting this. So if you see here, ship name would be same ship name, Federal Shipping, because this is the data related to only that particular slice. So C records will give you the transactional view of only that particular selection, whereas C data will give you the aggregated data that is composing this visualization. Okay, so yeah, we have focus mode and also we have option to view data at record level at an aggregated level. So we'll just to finish this assignment, we will get one more analysis. We'll do one more analysis with this data and complete this. So here, this is a tree map. This is a very special visualizations. With this, I can do the correlation study between two measures. So the study I'll do here would be across my shipmates, across my categories, shipping categories. Okay, I want to do study between shipping costs and revenue, spend versus returns. Color saturation, I would select revenue. Okay, change the color pattern a little bit. No. Okay, and change data label colors. So here label colors you can't change here. Data colors you can change data color. Font of the labels, if you want to change, you actually have to enable data labels, change the color there. So you see data labels also, right? And then you disable them. Yeah, the colors are changed. That's how you do it. Okay, so now we have here a tree map. So what study I can do here is, so you see here these two I am doing two correlation between two measures. One is shipping cost and other is revenue. So if you see the area of the tile, so these are tiles, each one is a tile here. So the area of the tile will reflect shipping cost, and revenue is the color intensity. The more the color intensity, the more the profit, the returns. Okay, you see these two tiles, they are equal in area, means the shipping costs, the spend on these two types of categories is same, but still the value proposition, the returns are more for poultry compared to this. You see this tile has least spending, less spending, yeah, compared to all others. The area is very less, but still the color intensity is somewhat average, means what, returns are better compared to this. So here this has least cost spending and least revenue also, that is okay. These two are average sized, so their color intensity is also average. Yeah, so the color is getting dimmer, so the saturation, you can see this here. So the highest intensity is this, maximum, and minimum, that is the lowest intensity. Okay, so this color saturation study is for revenue, color intensity, and size. Variation of the tile size is will give you shipping costs. You can add some more like trip type into groups and go and explore that by specific category or at a time or everything. Yeah, you can get that like this hierarchical. Okay, now we have more intensity color variation in domestic, yeah, in international shipping mates, domestic shipmates, like this. So we can do a better color study like this. Maybe these are the small tiles you want to contribute, so you can focus on ships like this. See, actually we can do one more study also. If you actually observe 1 2 3 4 5 6, these 6 tiles, the 6 segments are contributing to almost 50% of your business. See, the area will give you the costs, right? So you are spending almost 50% on this 4. So instead of analyzing this bunch of sectors, you can analyze this. So by spending that amount on 50% of your returns, you get the more benefit, because this is constituting to half of your business, these sectors. Yeah, so you can easily identify the more profitable areas also using this tree map. May not be 50%, but yeah, approximately 50%. Half the area they are covering, this, just this 5 sector segments tiles. Okay, fine. So what all we have done? We have got data sources from two new data sources from OData, Open Data, the data cloud hosted on web-based data. We have we saw how to do drill down in three ways: drill down and drill up, hierarchical drill down, selected drill down. We saw how to add reference lines, and focused mode, see records, record level, transaction level, yeah, see data, see records, and then this tree map, very interesting map to do comparative correlative study between two measures. Okay, and the one important thing that I want to tell here is, actually we are showing data on all these 3 visualizations from 3 different data sets. Shippers is coming from shippers data set, categories is coming from the category data set, and revenue, spend, the number of trips is coming from this data set. But still we are able to successfully create these visualizations without any much conflict, because the relations are well created between these 3 data sets. So that is a good thing. So we can create visualizations from multiple data sets very conveniently in Power BI. A single visualization can be created from multiple data sets very effortlessly. Okay. In this assignment, we will further do calculations using DAX, basic calculations using DAX. Okay, so we'll be working on the same dashboard that we created in previous assignment. On top of that, we will compose few KPIs and put some trends. So this is a dashboard that we developed, so we'll be using this from previous assignment. Let's create some calculations using DAX functions on this. So this is the data I have, trips data. So now on this time I will create a measure, set context. Okay, so the difference is, in our previous assignments we used DAX for creating new columns. So those calculations will be happening at row level. For each row, for each change in value, that formula is applied and the value is composed, and that's what we see as part of the table. Yeah, so this occupies space. On contrast to this, measures work on the sets of data. So you don't see a new column being added to the data set. So they will be composed and will be available on the fly. Let's do it. Let's create one measure. So I'll be creating a measure to bring revenue per load. So how much revenue is being generated per load. So for this, what I have to do, I have to take the sum of, see, as I type the formula, so it has IntelliSense to show all relevant formulas in the drop down. So you can pick a formula from them, and then there is help IntelliSense. So that will tell you what it takes actually for the formula column name. Okay, it expects a column name here, and now when you type the column name, it has again IntelliSense to pick up the columns that are relevant to the text you are typing here. Yeah, so I typed revenue RE, so now you can see that there. It's a very advanced formula bar that we got here. So sum of revenue divided by count of trip ID. So this will give me per trip. So this will give me per trip how much revenue is being generated on an average per trip. What is the revenue, average revenue? So this is a calculation. Okay, so this is how generally we do. So this, the moment I hit enter, so a new measure is created, and you can see that got added here. And you don't see that being added here, right? So that is because this is at a set level. So the calculation would be happening on the fly. Now you can use this measure very much as any other value in our visualizations. Just doing this arrangement, little rearranging this visualizations. Okay, so let's get that new measure that we created. So where is that measure? Revenue per load. It's added as a data card. Now let's shift this to a KPI. So per load I am getting this much revenue. Change this to 4K. Yeah, approximately 4K, 4.3K is the revenue generated per load. This is a KPI. Let's do some more KPIs. So I go create another measure. Revenue per mile. What is the revenue generated per mile? So here again, sum of total revenue. So instead of using divide operator, it's always better to use divide function. So we already used divide operator, we saw that how it works, right? So we have good advantages by using divide function over divide operator. Biggest advantage is if it encounters divide by 0. Yeah, if it encounters divide by 0 error, then it will not throw anything, it will not fail, it will not stop calculating, it will simply give us a blank value. It will give us a blank value. So that's one advantage. So divide by 0 errors can be handled by using this function. And you can also set what could be the alternate value. So now what I want here, I want sum of total miles. I'll take loaded miles because that's what gives me revenue. Sum of loaded miles. So this would be revenue per mile. Revenue per mile. What KPIs I have? Revenue per mile. Okay. Then I'll compose one more. Variance in loaded miles and total miles. I'll call them as dead miles. Dead miles. So sum of total miles minus sum of loaded miles. Okay, so now I got some measures here. Let's go and put them here. So just copy this, paste, paste, created 2 copies of this KPI. It's a card actually, it's a data card. So as you can see, this is a card. So the second one, so the first one is showing revenue per load. So second one, let's put, okay. If you unselect data, all the data fields from a visualization will disappear. Revenue per mile. This is revenue per mile. Not appropriate format. So we'll show it as number. So that's the revenue being generated per mile. Okay, and then here on this we'll show variance. So that's dead miles. So we have these many dead miles. Okay. So I'll do some formatting here. See, revenue per mile is actually a value, a monetary amount, right? So we will show that in some format. So I can do the format by going into modeling. So in modeling, I have bunch of options here. We saw already how to change data type and category. So now we'll see how to utilize other formats. So for this, I have to select the column, not the visualization. Column or the calculated measure. So I'll select this calculated measure revenue per mile, and I will set this as a dollar. So you can see now a dollar icon will appear, making that it is a numeric amount. Yeah, it is a very much numeric amount, revenue per mile. So it's same is the case with this column. So I can change the format and set to currency, and currency would be US dollar, right? Okay, so we can do formatting stuff like that. We can set that as percentage. Yeah, so now we can actually do that as percentage. Now this, so this is dead miles. So I want to see actually the percentage of dead miles. Percentage of dead miles over loaded miles. How much percentage of dead miles I have over total miles actually. Yeah, so we will do division of divide, because that number is actually not in a very readable form. So I can't figure out whether it is high, low, okay. So I can't make that kind of study there. So if I have to do proper analysis, yeah, bring it in proper readable format, then better show it as a percentage. So when I divide this difference by total miles, and I divide this difference with total miles, yeah, so dead miles would come up as a fraction, as a percentage. Let's go back and see. Yeah, so this would be now a percentage. Change the format back to a number. Don't apply any special formats. Okay, and now this is not in a percentage. So we'll go change the model, select the column dead miles, and change it to percentage. Okay, so that's so 37%. So on overall loaded miles, so 37% is the dead miles percentage. Little high, yeah, it should be always 10 or 15%. It's more than 1/4. So need to be taken, special care need to be taken here. Okay, so this is one analysis that I can make here. Okay, let's go and see this by all this information by um, a shipper. I have different shippers, right? I have outsourced, I have different shippers. So I'll switch this to a filter. So I can set up a filter like this. I showed you already. So in our previous classes, setting up filters. Okay, so we have filters here. So we can uh, select the required what we want to see. So if we see United Package, so it's not, there's no much variance. So dead miles are same, almost same for most of the vendors. Okay, so you can see the revenue is changed. There is a slight change in revenue, but yeah, so we can actually convert this into uh, general properties. We can switch this to a horizontal format, and we can get rid of header and make it something like this. So this is also a filter. Looking like a KPI, but it is a filter. So we can filter on this. Okay, yeah, so but header should be there if we want to reset it. So header is essential for resetting the selection. Okay, now there I go. I have a filter by company name. So I'll build one more KPI. So that would be the last KPI here. So what I'll do, I will calculate uh, percentage of on-time deliveries on overall deliveries. What is the percentage of on-time deliveries? Yeah, because that would give me good, that will give me good reputation. Yeah, so let's calculate that. So it would not be a simple straight expression. It will be a little complex, but don't worry, we'll understand that quickly. So I'll go and create a new measure. So here also in modeling tab also we have option to create a new measure, or we can go home and here from here also we can create a new measure, or we can right click on the table and say new measure. Okay, all three same. Okay, now when I right click there, here this measure that we added has disappeared. We'll get it back. So all these measures when I add, those are set level operations. So the formulas will be applied on the fly. So you don't need, they don't get stored. So they don't occupy physical space. So here I will write on time deliveries. So for this on time deliveries, so the function I would be using is, so what I have to do actually, so I have to count number of trips. Yeah, so count, so generally count trip ID. So yeah, so this would give me the overall trips, but that's not what I want to do. I want to count only those trips whose delivery status is on time. So here I have delivery status. I want to count only those rows whose delivery status is on time. So I will convert this function to count. So what we'll do, this will count the number of numbers in a column. Now I don't want to count numbers in a column. I'll convert this to a, count a. Count a will count the number of values in a column. So it will count by value. Yeah, and then I want count ax. I want to write an expression inside it, and based on that expression counting should happen, because I want to count only on time deliveries, right? So yeah, so I need to write an expression. So this is a function that I will use, count a, which says values x is, it's an expression. There was going to be an expression inside this. Okay, so what would be that expression? So that expression is, so a filter expression. So I'll use a filter expression. So the filter function will expect two parameters, a table and then the filter expression. So table would be here trips. So table now that is in use. Yeah, so this table, on this table I will write a filter on delivery status, which is on time, delivery status on time. So this would be my filter expression. So filter rows in this table whose delivery status is on time. Okay, now whatever is returned from this function, based on that count the values, count a. So count values based on that expression in the first part. So this would give me count of deliveries made. Yeah, so but now I want it as in percentage. So what should I do? I should encapsulate this entire expression into divide at the end, put trips at the end, put this sum of trip ID. That's it. So this would give me the percentage. So it is doing what? It is filtering only those on time delivery records, and we are adding that, and that counting, we're counting those rows. That count will be divided by the total count, not sum of, count of. So here I can use just simple count. Count will give me the count of trips. Okay, fine. So now put an enter on time deliveries. Go put a card here, not multi-card, single row card, and drag that newly composed measure onto this. Where is that newly composed measure? On time deliveries. Convert this to percentage. There we go, 72.85% of on time delivery, which is very good. Yeah, so we are almost 3/4, yeah, of our trips are in compliance. I can actually now see Speedy Express. Yeah, so this is low, 75. Federal Shipping 68, low. United 73. So United has more on-time deliveries. No, not United. Say Speedy Express. As the name suggests, Speedy Express has most on-time deliveries. Yeah, so we can do KPIs like this. Now that we have calculated KPIs using measures, now we'll do some more things here. So I have shipping days. Yeah, so I have shipping days. So each consignment is assigned for a SLA, ETA, estimated time of arrival, in another way if we have to term this. So here we have preset values. So I want to see by category. So I want to see number of loads that I'm categorizing based on the ETA. So one quick thing that I can do is I can get the ship days onto the canvas, and maybe I want to watch it by I want to put this on axis, and I want to see the volume um, for each category. So you see here we have like so we see SLS that set for 2 days we are more volume compared to others. Yeah, so 1 day, within 1 day delivery, 2 days delivery, 3 days delivery. But this is okay because now it max as a SLA is 10. What if there are more like 20, 25 payment term days? One can pay in 30 days, 40 days, 50 days, so like that. So I don't want to see. So this is now I am getting into a, a stage where I want to show numerical values on categories. So that's what this assignment is targeting us. So how to show measures numerical values on category axis. So we have certain visualizations built around this to show how to deal with that. Uh, Before getting there, yeah, I want to show these measures as bucket because that would make more meaningful as a categories as bucketed values. So observe how I will do that, how I will bucket these values. So for that, I would need a reference table. So far we saw how to create a column, how to create a measure. Yeah, create a column, create measure. Now for the time now, we'll create a table. Let's see how we create a table. Okay, so you'll shortly understand why I am creating this table. Okay, maybe not in this way. I'll not create the table in this way. I'll create it in more easiest way. Why like this? Enter data. Enter data. I can keep entering data here. If I have a data already in Excel sheet, I can simply copy and paste here. It's as simple as that. Okay, yeah, so here column name would be uh, days category, and next column minimum days, maximum days. Okay, now the buckets would be 1 to sorry 1 to 3 days would be one bucket. 4 to 4 5 6 6 would be another bucket. 7 to 8, and last bucket would be 9 to 10. So all the values that are falling between these days should be categorized as one single unit. That's the aim here. Okay, I don't want this extra column. Delete. The minimum days here would be 1, 3, 4, 7, sorry, 7, 8, 9 and 10. There I go. I have a table now. So give it a name. Days categories. Okay. It will shortly will be added here. We'll get it. Yeah, you see, now we have that here, days categories. So now this I will use to create a column in my existing data. So I'll not create a column. I will go and I'll create a measure, and now see how I write this measure. So I'll name this as I'll be doing this on ship days. So ship days categories. So that would be, so I'll be using a function to write an expression. So the I would be using calculate. So calculate is a function where you can write expressions and filters and stuff. Okay, calculate will be very handy function. We will use it more. So this session and the previous session was are on basics of DAX writing. Okay, so we are doing basic calculations. We have more sessions on advanced DAX to understand it better. Okay, so now we'll use this function, and I will count. This time I will not use count A or count X. I will use directly count rows. Straight away count rows by applying a simple filter like I used earlier. Okay, filter what? Filter trips table, filter trips table. So here I would be writing an composite function. So I will use and conditional statement. If I think I have put one more extra brace here. Yeah, so if ship days, yeah, ship days are greater than equal to I'll go for ship days categories. So that new table that we created, days categories, mean what is the name? This function will stay here, no need to worry. Yeah, max days, min days, fine. If this is greater than min days and same function less than or equal to max days. If it is falling between min days and max days, yeah, there I go. Count the overall rows. Count the overall rows. Count the rows from trips if the trip ship days are falling between these values. Okay. Now it is throwing some error. Yeah, because they should participate in some aggregation. So we know that we don't have multiple records there, but still this expression will not understand. So we'll simply use one dummy uh, aggregation. It will be applied at row level. So now that it is applied at row level, we have only one row per category. Ideally it will not do any max, but still we need that here to get rid of that warning message. Okay, now the expression looks correct. So we are doing the comparison ship days between min days and max days, and if it is falling, then count that trips, count those rows. Enter. There we have. So this now I will use it here. ship days, I will not ship days, I will go and use ship days categories. Okay, ship days cat. Why I'm not able to use it here? Check out this. Okay, as a card. Ship days categories. Fine. So this should be combined with categories, the actual categories. Now we are actually counting only the variation between them. Unless we bring this, don't see the actual category. Okay. Yeah. Now you see the category. So between 1 to 2 days, 2 to 3 days, this flip it to bar chart. Okay. So clearly we can see now. So this is the count of trips. So what we have done earlier, we were showing 1 2 3 4 shipping days in just plain numerical values. Now we have categorized columns. This is also called as binning. So we have bins, we have categories like this. So we can clearly see that most of our deliveries are targeting for 1 to 3 days, between 1 and 3 days. Then next is 4 to 6, and 7 to 8, 9 to 10. So these buckets are almost same. Okay, let's understand it better. So now this I will split by trip type in category access. I will put it as legend. Yeah, now you see, so this in focus mode. See, uh, this slice says that these are intercom. Intercom means within a factory, within a company. Okay, like a shuttle, inter-shuttle kind of transportation. Okay, then we have domestic, then we have international. See, all our international deliveries are ranging between 7 to 10. Yes, that is correct, right? So they'll take more days. Yeah, so the data is correct. So, but there are some international deliveries which are falling in 4 to 6 days bucket also, which are on par with domestic deliveries. Means what? These domestic deliveries are taking lot of time. This bucket need to be specially analyzed because it's taking more time. Okay, now if you see here, there are gaps. Means what? Within this bucket there are no intercom deliveries. Within this bucket there are no intercom, and there are no domestic deliveries. That's why we see blanks there. So that legend is not coming up for all. Okay, so this is a share of intercom. So all of the deliveries are within 1 to 3 days. Then domestic are between 1 to 6 days, and this is a split. So this is how we actually can show measures. When we are showing measures, we bucket them, and bucketing is done in this way in Power BI. Yeah, so that's how we do bucketing in Power BI. So we have to create a reference table, and on using that reference table, we create a function. So if you see, actually in this function, it nowhere gets the categories. We are not using days categories in this function. We are only using min and max days of this table, and we are only getting the trip. Now when we put it on visualization, we use categories in the visualization, days categories from that newly created table. So that will take care of bringing in the counts as per the bucket and composing this visualization. Let's do some more visualizations. I want to see the difference between target days and ship days. I mean actual delivery days and ship days. Okay, so I will pull ship days and delivery days, ship days versus delivery days. I will put this as a line chart. Okay, and on category axis I'll again put ship days. Okay, I'll put ship days and I'll do sorting. Sorting is not allowed. So instead of actual days count, because this is actually doing the overall count, which will not be accurate. So I want to do average study. Average of this versus average of this. This would give me the correct data. Yeah. So you see now, so I have two measures here. So you see the black line is representing the target ship days, as in actual ETA, estimated time of arrival, and this is delivery days. Okay, if you see up to 4 days, our target when it is up to 4 days, within 4 days both are in line, means the lines are going linearly, means there is no deviation, means uh, for the timeline that we have set, the delivery timelines are matching, are setting, they are in compliance. Okay, if this blue line is going beyond this black line, then we have a problem, means our delivery days are more than the actual days and then the ship days, but the line is going downwards after that. So as the number of days are increasing ETA, we are doing good. So if you see here, so the average delivery days 8, average ship days 10. So we have set at SLA, ship days is an SLA of 10 days, which is ETA, expected time of arrival, but we have delivered it in 8 days only. So that's why this line is downwards, which is a good indicator, which is a very good indicator. If this line is inline to this, both the lines are parallel and coincident, then it is not good, not bad, it's okay. So we are meeting deliveries on time. Okay, so this is one good way of representing this measures, scalar measures. Okay, next thing is, this is an overall study. We do have we do have undelivered shipmates, late delivered, early delivered. So but when you take an on average, we are doing good. Okay, we are doing good. So the another study that we can do is, we can use uh, scatter plot. We can use scatter plot to actually, what I'll do, instead of starting from scratch, so I will copy this visualization and I will switch this into a scatter plot, because I want to do that comparative study on same kind of data. Okay, okay, now this I will add one category. So in scatter plot, what happens, it will lay points for each data point. So this would be X, ship days. Instead of ship days, I will take it by destination city details, average of delivery days and average of ship days on X-axis. So this is a correlation study. I have and the volume. And the volume on size, not size, go for color saturation. Actually color saturation, okay, this is not right, so this should also be count of. Okay, so these bubbles, so we right now we can't control the size of these bubbles. So we have average of, oh, here we should be having it as average. Okay, so there you go. So now here what it is saying is, has, you know, um, this is on delivery days, this scale is on delivery days and this scale is on ship days. As ship days are increasing, so towards the right side ship days are increasing and towards the top delivery days are increasing. See, when ship days are increasing, yeah, and delivery days are increasing, so this quarter, you see this quarter, this is okay, this is normal, because ship days are increasing and delivery days also increasing. That's why it is on top quartile. But you see this data, these data points. You observe these data points. These data points, if you observe these data points, these are doing good. These are doing really good. Why? Because these are on the extreme right side. Means what? Number of shipping days are increased. So for these points, shipping days are more. Okay, the shipping days are more, but they are not on extreme top. Means what? Delivery days are not more. Delivery days are less. So these are the cities where, if you see, if you point, ship days are 4, but we have delivered it in 3 days only. Okay, so 5, actual SLA was 5, but we have delivered in 3 days. So these are the points where we are doing good. So if we study these points and understand the business models implemented on in those cities, or is it because of the local conditions, we can enhance or we can improve our business. Yeah, so we can do uh, colors formatting, show all. Yeah, we can do all this. Yeah, bubbles, we can fill, can do colors by bubbles. Okay, you can fill them. Yeah, so this is scatter plot. Scatter plot is also useful for doing correlation study between two measures, just like tree map. Okay, but it is more advanced. Here we can plot the entire data on the visualization, and we can study the we can identify the patterns. We can identify the focusable areas, where we can lay our, where we can put our focus and do comparative study, like that we did here. So these are the cities where we are doing extremely good. Though the shipping days are more, delivery days are less. And here these are okay, these are okay. But you see, there are no points here. Means where shipping days are less but delivery days are more. So this is a good transportation company. So because here we don't, they're not slipping very heavily on the estimated arrival time. Yeah. So I have discussed some these filters, right? We can actually put more advanced filters here on these visualizations. So we'll do some squeezing here, more squeezing. Maybe because I want to do this study based on a state. So I can go and I can pick destination state, put it here, and so now that this is a state, so auto intelligence will plot it as map, but I want it as filter. So on this filter I can actually enable features like uh, search box if we actually have more values. Yeah, now it doesn't make much meaning here, search box, and we can have options like select all. At a time you can select all states and unselect the ones that you don't want to do study on. Yeah, your data will get changed accordingly. Okay, so we can put a slicer like this, destination state slicer, somewhere in between here in the real estate. Okay, yeah, or I can move this to the beginning, which makes more sense. There you go. I have destination city filter. Based on that, I can filter this entire analysis. Okay. In this assignment, we will be targeting Power Query. So we will be getting an introduction towards how to use Power Query, uh, the benefits of it, and make an audit dashboard on this transportation corporation data. Okay, so this is assignment that we'll be covering as part of this session. So to start on, I will set the prerequisites. So here, um, every every load that a truck carries, every load, so each transaction here is a trip, right? So it has the source city, destination city, and arrival time, all that. Fine. So it has also a auditing mechanism, like each trip should cover certain checkpoints. While a truck is going from destination source A to destination B, it should cover some checkpoints in this course of journey, say like 4 checkpoints, 5 checkpoints. So there would be some checkpoints where it has to get filled, fuel, and then refreshments, driver change. So there would be some compliance stuff that a truck driver should take care of. Okay, so here the data is recorded at a transaction level, I mean at a trip level. So how many checkpoints each of this trip has covered. Okay, so here we can see the data checkpoints. Okay, how many checkpoints have been covered, but how many checkpoints were assigned for each of this trip, each of this trip ID. Say like for suppose this trip, okay, this trip for this customer from this source to this destination. So how many checkpoints were assigned? Okay, now it says that we are 10 checkpoints were covered, but were there 10 checkpoints? Did it cover all the checkpoints assigned to that or not? For that, we have to get data from a online system. So now we will connect to a RDBMS data source. This is the time we will now connect to an RDBMS data source. So for that, I'll be getting data from SQL Server hosted on cloud, which is Azure. Okay, so I'll pull data from Azure service. So because that recording happens online, so to their centralized system. So when a truck passes through a checkpoint, that information will be sent to that centralized system. So that is being recorded in Azure. So Azure is nothing but SQL Server on cloud. Okay. So I will quickly first log into my. I have set up that thing. So this is as good as connecting to a SQL Server database or an Oracle database. So I'll do a quick login just to get the server credentials where the database is hosted. One can easily set up Azure portal access. It's no big deal. So it's free. They'll give some credit for some time. Okay, so you can try out. You can set up a database. See, that is a free credit that I have, which is showing here. Okay, so I'm utilizing that. I'm on free trial now on this. So this is a database that has been set up. Okay, so that the one you saw earlier was a dashboard. See, this is a server name. So all I need is this server name. Okay, then I can access the database. So this is a database, Lands Transport Corp. So this is a database name. It got that centralized system tracking data of checkpoints. Okay, so I'll select Azure, click on Azure SQL database, connect. So I have to give server name here. The one just I copied. Okay, so this is a server name which is on Azure. Okay, so here now when you get data from Azure service, you have two options. Either you can directly import the data into your system, or you can run it as direct query. So these options will be there only for non-files data. So for files, always it is import. If you are getting data from a non-file, then yeah, so you have that option of directly linking it. So nothing will be stored in the analysis file. So it will have only reference points, as in then the analysis gets loaded or refreshed, so data will be brought from the live system. So that is direct query. Import is data is directly embedded into this analytics file. Okay, so when we are connecting to RDBMS data points, data sources, we also have an option to write SQL statements here. So this is a panel where we write SQL statements, set command timeout. There are some of the advanced properties that we got here. Okay, so right now I will import the data, okay, into the system, and so I'll click OK. So you might be getting doubt. I said all files will be directly imported. There is no direct query option. What if the data changes in the file? All you have to do is make sure that file is in the right place where supposed to be, and click refresh here. The latest data in the file will get loaded automatically into the Power BI analysis. But unless you click refresh, latest data will not reflect if it is file. Okay, so this is the database, this is a server, this is a database. In database I have these two tables, checkpoints and checkpoint points. I'll pull these two tables into Power BI analysis. Okay, this is a different way of getting data in the system. This is real-time data. Once I get that here, I'll tell you the model. It's loading the data into the analysis. Okay, so here we go. So we got checkpoints. So checkpoints are, you know, the actual designated halts. Suppose vehicle supposed to stop there. So these checkpoints have there's some names and then the IDs, then the flags like information like they have fuel station, they have refreshments, it's an interchange point, they have warehouse, the service center, and it's active, the checkpoint is active at the moment or not. So this is checkpoint information. Then we have a many to many mapping relation table, checkpoint trips. So these are two tables that we got from Azure database. So this will map trip ID to checkpoint ID. This is many to many. A trip will have multiple checkpoints. Multiple trips can pass through a checkpoint. Okay, so this is a relation how it is created this table. So it will do the mapping. It will see the trip ID and it will check whether if the trip has passed the checkpoint, it will make an entry into this table. Okay. So now we'll go to relations. We'll understand the relations here. We'll spend some time in understanding these relations. If the key namings are correct, if they have correct key names, then the relations are automatically created. Okay. So if you can see here, so these two tables, categories and shippers, that we got from Open Data. Yeah, Northwind Open Data. So these two tables we got from Azure. So you can see these are the checkpoints, and these checkpoints are linked to our actual data with this many to many link table. Okay, so what it will do, it will join trip ID to this trip ID and checkpoint ID to checkpoint ID. So you open this relation just to check out. You see here checkpoint trip ID is mapped to trip ID in trips, and here checkpoint ID in checkpoint table is mapped to checkpoint ID in trips. So this is a, and you see here this is many to one. So this is many to one, and this is here many to many. So the actual many to many relation is established here. So you can see this is one to many, and this is also from one to many. So the many to many established relation is broken down into a link table, the help of link table here. Okay, so this is a kind of normalization. It's called fourth normalization. Okay, so that's how a data model is created. Remember this is a reference table that we created just on the fly to create buckets. Yeah, so we don't need to link this table to any existing tables here. Okay, so now we have this. So another important thing that I want to mention here is, so when you mark a table as, you know, cross filter direction as both, when you set this feature that cross filter direction can apply to both, okay, it means that if you filter by checkpoints, if you want to see per checkpoint how many trips have been covered, yes, you can see for checkpoint how many trips were covered, you can see. At the same way, per trip how many checkpoints were covered, yes, you can see that. So this is both way, you know, filter can work in both ways relations. So that's why we actually by default also all the relations gets created in bidirectional. So these are bidirectional relations. This is different, this is nothing to do with this link, this one to many, many to many. This is the cardinality actually. So the, the thing I am telling you about is bidirectional filtering. So that is like per checkpoint I want to see how many trips were passed from that checkpoint in a day or in a year, that I can do. So from here to here filtering. The same way per trip how many checkpoints were covered from here to here. So that is bidirectional relation filtering. Okay. So that's that is possible with Power BI. You can click manage relations and view all the relations at a time, whatever the relations are there. Okay. And yeah, now it's the time to get into Power Query. So these assignments were targeted to cover Power Query basics. Okay. So Power Query here can be browsed by clicking on this edit query. So if you click on this edit query, it will open a panel. Yeah, this is a panel where we actually do Power Query stuff. Okay. Yeah, you see this, all the tables will reflect here. Okay, it has bunch of options like transformation, so like column formattings. Yeah, here in this first panel we do a lot of column formattings, transformations, edit column transformations, column level, table level transformations, column level transformations. So you can do lot of data modeling stuff. This is different from DAX. Okay, so this is different from DAX. So this is Power Query. So in everything you write here is also called as M. Okay, we don't actually write anything at least in this assignment. So we will actually use all these options that are available here in this transformations panel. Okay. Uh, the first thing is if you want to modify any existing data source pointer, so we have like data coming from Excel sheet, maybe if the path has changed, yes, you can change the source again. You can select the relevant path, or the credentials has changed, or the link URL has changed, you can. So in this analytics we are getting data from 3 different sources. All the sources we can see here. We can set permissions, we can do things around changing the data source properties. Okay, I'll do a basic transformation. So what I'll do, we have some inbuilt intelligence options here. So I will extract from ship date, I'll go to transformations, and in date transformations I'll take uh, week of the year. What is a week of the year? So I just click on that, so you check out what happens. So ship date now is created as week of the year. Okay, so this is now changed. Ship date is now changed into week of year. Okay, so maybe this is not how I want to do the transformation. So the good thing here is, so any transformation that you apply on a table, any transformation that gets applied on a table can be viewed here. All steps will be listed here. Okay, so if you don't want that calculation to take place, you can simply uncheck that, and take that transformation out. Okay, so we have that options here. We can set the data type here on the fly. we have all data type options. We can filter the data that we don't want. Okay, so extract, we can do extraction. Okay, now what I will do, I will duplicate this column. I will do what? I will duplicate this column. So for that we have an option format where in home keep row split. Yeah, so this is copy of ship date, and this copy I will only show week of year. Okay, so now I got this as a new column. That's what I was looking at in the first place. Yeah, you see, it gets added as a new column, week of the year. So we need to go to add column panel. We need to go to add column panel, not here. In the transformations, it will do transformation of the existing column. Yeah, that's not how I wanted to show. Yeah, so that's one way of doing it. We don't want to show the column the current format. We want to flip it altogether to a new format. We can do this. Now here I added as a column, so I extracted. So this is not DAX. Okay, remember, this is not DAX. So this is like, you can see here, transformations, go home and choose advanced editor. So it will just show you. So this is the Power Query language here. So you can see here, so this is add column, week of year. It is extracting and adding as a column. Okay, so that is a step again that we see here. We will simply name it as shipping week. Okay, shipping week. And in addition to that, see, just like number on when you represent it on a visualization will not make much sense. So what I will do, I will do a little transformations, further transformations. What I will do, I will format, add prefix. Prefix would be week. Okay, yeah, this looks neat. Now save this. So we will cover more these transformations more. For now, I just wanted to show the overall view, how it looks. We got transformations. We can directly apply on the tables. We can add columns with functions. So all the steps that we do will be listed here. At any point in time, we don't want certain steps, we can remove them. And once we are done with this Power Query thing, we need to click this, close and apply. Or apply. So then that will reflect into our actual development environment. Okay, so where we have reports, tables and relations. We just came out of query window now, Power Query window. Now you go to tables, check out trips, on trips we should find this. So if you click on this column, you don't actually see any formula here. You click on this, you will see a formula here, because this column is created by DAX. So this is a DAX formula. But if you click on this, it's nothing you see here, because this is created by Power Query. Okay, we can do much advanced things with Power Query. We'll discuss that. Okay, now let's build a new dashboard. call it checkpoint analysis. So I will now show you that many to many bidirectional filter, how it actually works, and all that things. So I will first do what? I will first get destination city. Okay, there I have destination city. I will change it to a side by side stack bar. On this I will show first how many checkpoints each trip has crossed. So checkpoints, yeah. So yeah, the aggregated number of trips were crossing these checkpoints in these cities, these cities. Now I want to compare. I want to do a comparative study, like how many were actually intended to be covered. So what I'll do, I'll go to that table where we had many to many relations, so checkpoint IDs. So these checkpoint IDs I will pull into this bar diagram. Count of checkpoint IDs. Yeah, so count of checkpoint IDs. So this is my target. This is my target. So this would be on trip per city. Okay, per city per trip. So we are adding all those checkpoints at a trip level. So that's why count. Here we don't need to add. So at a trip level, okay, because at a trip level this is already added and we are seeing the data. So at a trip level we have this information, like this trip ID has covered 7 checkpoints. But if you actually go to that table, then we see that trip ID. If you map that trip ID, and we will see how many checkpoints were covered. So that count is what we are getting here, count of checkpoint ID. So this is a target. So this is, you can rename to make it more readable. Target checkpoint ID. So these are the targets that need to be covered. Yeah, okay, so this is actual checkpoints that are covered and count of targeted checkpoints. So this is a variation. So you can see here, mostly most of the states that is meeting. Okay, so but here if you see, in some states target checkpoints are more than the actual covered, and in some states more checkpoints were covered than they assigned, so more delay in the delivery. So these are the states where trucks are heavily getting broken or halted or stopped. That's why they are covering more checkpoints than the intended actual. Here this is a perfect. In this destination city, all the vehicles going towards this destination city are perfectly adhering to the compliance of the checkpoints. Okay, so that, like that, we can do comparative study of this is a kind of auditing dashboard. Okay, now we will do a actual view. Here we will see the transactional view. So for that I will pull a table visualization, and in the table visualization I will select fields like the trip ID, actual trip ID, just click select on that trip ID. Okay, then we have customer, origin city, destination city, targeted ship days, trip type, and some more fields from other tables like shipper, category, and finally the auditing information. So how many checkpoints this trip has covered and how many were intended to be covered. Sorry, not this. Yeah. So this target should be shown as count. Okay, there you go. So we have this detailed visualization. See, it has an intelligence to put up total line for numeric columns. Here it doesn't make much sense. So what I'll do, I can take that out. General, we can take out totals bar. Okay, now we can see in detail this data. We click on particular destination city, the data related to all the destination city will be visible here. A single click, ascending, descending, sorting, you can do sorting also on this data. Okay, so this is a detailed view. We can put details views like this with table visualization, but the thing is right now at the moment table visualizations doesn't support row level selection. You can't select a row in this table visualization. That's not possible. You can select that only on bar charts or any other visualizations. Selection within a table visualization is not possible. Only overall filters will work. Okay, I'll put one more filter. So this time I will do aggregated study, not like a transactional study. So for that I have to go for matrix. So get matrix here. Matrix, and in this matrix what all I'll pull. First I'll get the trip type. Per trip type we have domestic, intercom and international, and players in this each category. In each category we have, okay, all three players are uh, doing business in every category. Okay, and then we will put categories also. Yeah, so these are the categories within each Now on this I will put checkpoint adherence, like so actual checkpoints values would be checkpoints, and then go to this and get targeted checkpoints. See, so we have totals, subtotals for each level. Automatically they have come up here, and we have data like this. What we can do, we can actually put this trip type in columns and can view data like this also. Per within domestic, how is the variance? Okay, let's, before doing that, do some formal arrangement of columns. Yeah, then get this into column. So this is a normal mat. Generally in Excel also we compose, right? We have some options. We have some nice formatting options that are available here, like you can go and change the style of this matrix. For example, this I like, and we have also like this. black header, I'll just flashy rows. Yeah, this is good. Okay, okay, fine. We can add one more column onto this. We can put by origin state. It's okay. Yeah, this visualization is good. So now we do what? Now we remember we have extracted week numbers. We'll see this trend by week. This compilance, how they are adhering to the compliance by week wise. So instead of destination city, I will use the column that I created, the new column. Where is it? Shipping week. Yeah, there we go. This is week wise adherence. We will split this into line chart. Okay, so the adherence is good. So we see always the number of checkpoints covered are never going down below. So here in some weeks we see lot of variance. For some weeks the difference is more, so the compliance is less. Okay, and some weeks they are uh, aligning to each other, so where the compliance is good. So like that we can understand. See, one more thing I want to show in this modeling is, we don't in this general modeling is, see here week numbers are not properly sorted. Yeah, so we want to do that sorting. So what we can do, we can select that column. See, 1 10 11, that's not the way, because it's a text column, right? So that's why it is doing on text based sorting. So we can do custom sorting. Select week number. Where is week number? Yeah, shipping week. And we also have week of the year, right? Do we have it, or we lost it? If we don't, we will compose it. We have shipping week. Okay, I have directly appended that. Yeah, I have directly appended that. So what I'll do, I'll create a new column. So just to pull week number. So for this I will write, uh, I will go to Power Query. I'll not do, again write a DAX, but that's not what I will do. I'll go to Power Query. I'll add a new column, and from ship date I will extract week number. So I did this already, but what I did, I got week of the year, but then I selected that and I went to transformation and I prefixed some text. Like in formatting, I prefixed some text. So that's how I got this. Now I'll not do this. I'll keep this column as is, this new column, and I'll use that column for doing custom sorting. See, I could have created that column using DAX also, but this assignment is more often Power Query usage. Okay, so now we have this column. Now this column should get sorted based on this column. How do I do that? Select the column that we are supposed to sort, shipping week. Select that column, go to modeling. In modeling, we already saw how to change data types, categorize them, do a dollar symbol or percentage, these options, right? Formatting and properties. We also have sort option here. Click on this column, we can select. So this is the default sorting happening based on that column. We can change, we can select on what column the sorting should happen. So see here now, week 1 2 3 4 5 6 perfectly sorted. Yeah, based on that column. This is custom sorting. For this you don't need to go to Power Query. Here that we have it in data modeling. Data modeling, along with adding column or measure, we can do custom sorting also. We have explored all these features in modeling. Okay, we can add new page from here also. Instead of clicking tab, we can add new page here or duplicate existing page. Instead of clicking on visualization, we can click here and add a new visualization and later select what kind of visualization it should be. Yeah, we can add text box images like we do in PowerPoint or Word. Yeah, we can do things like that. You can go and manage relations from here, or we can click here and see all the relations that are there on the table on one go here on this manage relationships window. Okay, so now I completed a proper dashboard analysis. Now in this for this corporation, from the data they have given us, we have constructed a dashboard, overall overview kind of a dashboard which gives you a brief peek into the data. And then we have built one analysis file for delivery analysis to do the delivery analysis, then also a checkpoint analysis. Now we'll save this and we'll publish this. Remember, when you're publishing, don't select any data because it will get saved and published in the same manner, and always be on page 1 while publishing. So now click publish. So it will ask us to sign in. Yeah, I have to do the sign in. Yeah, so I did the authentication, I signed into the application. So now it is asking whether to replace the data set. Yes, and now it is publishing this to the Power BI cloud service. So see, the desktop client is free. Anyone can download this and start building applications and share the file. So when I save this, it actually gets saved as like this, a file. Now when I publish this, this will go and sit on cloud service. So for cloud service, you need to take subscriptions. So those subscriptions are chargeable. So $10 per month right now, but we can set up free trial. We can set up free trial which is for 60 days. So I am actually using a free trial now. Just we'll get rid of this. So it's going for second authentication. So we just finished authentication here process. So now that DXP, the local DXP will be published onto this cloud service. Okay, so now we can see all those three panels here, all those three dashboards here. From here I can specifically pin visualizations onto the dashboard. So remember, we already created dashboard in our first assignment, Lance Corp dashboard. Yeah, we already pinned some visualizations there from our first dashboard. Now we're pinning from our second and third dashboards. Okay, and this trend line, pin this trend line also. Okay, now you go and check out that dashboard. You see more visualizations now here on this panel. They have to stabilize this. It's still not very user friendly arranging the styles here. Okay, so now you see here, this is the dashboard we got. Now we can go into full page mode. I look at this dashboard. So now this page is coming from delivery analysis. Now I click this, it will take me to delivery analysis tab here. Yeah, back. Now I have seen this checkpoint analysis. Okay, and now I click on this. I'll go to checkpoint analysis panel. So these are the dashboards that we prepare, and deploy onto cloud service. Anybody access to this cloud account can analysis files. We can share them. We can share the dashboards. We can share, and we can also publish. We can embed the copy and we can publish. So we'll start our next assignment 5. So in this assignment we will cover data transformations, more data transformations using Power Query. Okay, and we will be utilizing a new data set for this assignment, which is state university admissions. So I'll give you a little walkthrough of this data. I'll give a brief overview of what this data is. So this is the number of applications received by various universities located in USA. So we have data like the institution ID, institution name, school name, and the university it's affiliated to, number of applications received, the total number of applications received, and then the split by foreign applications, Hispanic, Indian applications, Asian, Black, specific. So race wise, number of applications received in each university in each state. Okay, so this is a main data set, university applications, and then we have a data set which will give us the information like how many universities are there in each state universities, and how much fund they are receiving, state fund, and how much trust, so the accumulated fund they have with them, okay, per state. And these are the targets. So these are the targets. Number of applications should be received by each state for various years. Okay, so now we are in 2010, so the data is from 2010 to 2016. Okay, so this is a data set that we have. So this data set now I'll take into Power BI. Okay, so this will create another instance of Power BI desktop. So we'll be performing all these transformations using Power Query. I'll close this. Okay, so let's get data from the university admissions. Oh, there is a problem here. Okay, so actually what happens when you're trying to access files which are prior to 2007 release, so which has XLS extension, yeah, so we need to have special drivers for that. Yeah, there I go. So now I got 32-bit access drivers, so I'll install them. So actually Power BI also comes in two versions, 64-bit and 32-bit. Based on the operating system we will install the 32-bit or 62-bit. So here see, this is Power BI desktop 64-bit and this is 32-bit. Okay, I'm putting the access drivers. This will help in reading Excel files prior to 2007 release. So I got these drivers from this website, so you can download from here, access drivers. Just when you click on download, it will ask which version you want. This is 32-bit. If there is no extension mentioned, it's 32-bit. Generally it would be mentioned as 84 or 86, not very sure, but for 64-bit it would be clearly written as 64-bit. Okay, so the installation is over. Let's get back to the file. So you can actually clearly see here the problem, that why it is unable to read that Excel file. Now retry. I'll get the data. So let's get all three sheets into Power BI desktop. Set tick load. No need to set preview now because we know already what data we are pulling in. Okay, so what is happening is now the data from all the sheets is getting embedded into the system, and table, schema, data model, everything is getting created, detecting relationships. Yeah, so see, now we got all three tables here, and then if there are any relations that will be created. I don't think now we have any relations here. Okay, yeah, let's get back to the data. So we have state-wise target, state-wise universities, and then university applications. Fine. So let's rename them. Give proper names to these tables. State targets. So these are university funds. University funds, and then applications. Simple name. Okay, so we got applications, we then got targets state-wise, and then we got funds universities wise. I think even this data is at university level, state level, state targets and state funds. Funds state-wise. Okay, so now after loading this data, so this is the university data, right? Okay, after loading the data, I realized that there are some more applications in a different data sheet. Okay, now I want to get that data as well. Okay, uh, like so here we have university admissions data, right? So actually if you see, there's another file which got charter as in these are state universities but ran by private organizations. They are under private management, but they get funds from the state. Okay, so here, so they are more accountable. The accountability will be high in such institutions. Fine. So now I have data here. So these are the applications received by charter universities. So I want to take this data into Power BI. So go Excel, take charter applications. So this version is different. XLSX. Earlier was XLS. Yeah, open. Once data is loaded into Power BI, you don't need to bother about which version of Excel we are getting that data from. Okay, now this is the table we got here. Charter applications, right? Yeah, so now I don't want to have two data sets separately because both contain same data, same number of columns. Sorry, not same data, same metadata, same number of columns, column formats, everything. Just that we have different data sets. Now I want to append this data set to this. I want to make this as part of this. So what I have to do is get into Power Query, Query Editor. Query Editor. So we'll start with appending data and then we'll explore all possible data transformations that we can do on data using this Power Query Editor. Okay, so we have applications. This is a table. Now on this table, I want to append charter applications data. So now I select this table. Okay, and go here. So here we have options. So you want to merge queries or append queries. So in our case it will be append queries. Append works as union in SQL, union all. Okay, so here we have options, append query or append query as new. So it will append that new query and create a new table. Now I don't want to create a new table, I want to append to the existing table, so this table itself. So it's like two tables or more than two, it's just two table. What is the table that you want to append? So this is the current table. Now we are in, for this table we will be appending charter applications. Okay, yes, the appending is completed. Close and apply. We'll just verify that. Open this actual admissions file. So how many rows we got here? We have approximately 4K. Yeah, we have approximately 4K records. Now you see here we have 4K. Data didn't get reflect. Okay, actually we have to do refresh from the model. Yeah, so the refresh has finished. So now you can see now the total has increased. It's now reflecting 5000. So earlier it was 4K, now we have 5K records, so 5K applications. So that additional applications, charter applications, have been appended to this original set. Yeah, now that we have appended data here, can we delete this? No, we don't need this, right? We can delete this. Can we do that? Try. It will throw an error saying that this cannot be deleted because it is being referenced in another application, in another query applications. Yeah, so actually that is a virtual join, I mean virtual appending. So there is no actual data integration into this table. It still have data on this table, but it has created a bridge. So we need to have this table, but any expression that we write, any function that we write on applications will reflect on both the sets. We'll treat as one single set in applications. Okay, the main table. So we have the entire set of records here in this main table applications. So now I'll do I'll do some text functions. So text functions like, so here you see institution name. This institution name is a combination of university name and state code, CS California. Yeah, so here we have state code also clubbed with institution name. We don't have that column anywhere else in the data set. We don't have that state code again anywhere else. That is essential for us because you see the other two data sets, they are all led by state code. So we need to have that state code separated here. So how? Let's do that here. So select the column and select split columns, split columns by delimiter. So how will we split this? So what is a delimiter? I mean, what we can see that each word is separated by space, but every word is separated by space. So I can't split by space. I get a lot of words. So we have advanced features here, advanced settings that we can rely on. So first we select the delimiter, the separator, word separator. In our case, it is a space. Yeah, space is being, and split by what? At the leftmost delimiter, rightmost delimiter, or each occurrence. In our case, it happens to be the rightmost delimiter. We can write more delimiters. If you don't have any, we can type the delimiters if it is not available in this list. So okay, so click OK. Now the column gets splitted. Yeah, we have a new column now. Let's rename these columns. Leave this as institution name, and this one state code. And so this is one of the basic text operations that I have done. So we can do more text operations, like we go and you see the school name. Yeah, school name, it's all in small letters, right? Let's increase the readability of this column. Select this. There are more transformations. In transformations, format, capitalize each word. I like this option. So capitalize each word. See, now it will get camel notation. So anything you do on transformations, you don't need to worry. It will not create any new column or anything. It will replace the data in the existing column. And you can see for every action that we are doing, a new step is getting created. At any point in time, you can move back and check what the data was at this point in time. What was the data at this point? Yeah, you can actually check. If you don't want a particular step, you can get rid of that here. Just click here, it will be cancelled. Okay, we'll come back here. We have more options here, like column level options. We can format text, we can set the type, we can set the data type, we can strong type, we can rename, fill empty values. You have empty cells you want to fill with the preceder or the successor, filling down or filling up, replace, pivot. Yeah, we'll come here, we'll come and we'll explore all these options in detail. First we'll go to other data sets. So here I have state targets, right? Yeah, let's start with state funds. So this table is good, but actually if you see, the column names are not properly aligned here. So I have an option here. So you can go and do use first row as header. Use first row as header, or use headers as first row. So we got this option. So I'll select this use first row as headers. So yeah, there I go. So I have columns here and names, but this is not correct. See, right? See, these are states, but under states I don't have universities, funds and all. So this data is in flat mode. So I want to transpose this data, then it becomes meaningful. So I will take this step temporarily out. I'll not do that step. So before doing that, I will do a transpose of this data. So select the table and say transpose. Flip the data. Now it is more readable and more convenient. We can easily do the reporting. We can establish a join between our applications and this table using state code. and we can retrieve state-wise number of universities and the funds they got. So what are the options that you see here in this ribbon? Transform or add column. You can see most of the options here also. Use first row as header. Okay, so this is a valid, proper data table. Best suits for reporting. Let's do similar stuff here in state targets also. Here we have to be little careful here. You see here we have state codes and then state-wise target. So what I have to do is here two operations. See, the first thing is I have to do a pivot of this data. But before doing that, I have to transpose this data because I want to do pivot year-wise. Yeah, you'll understand that. We will see. First, we will do the transpose of this data. So I have state names, state codes, and then years and year-wise targets. Okay. Where did state code go? Okay, so state code will disappear when you do transpose on this kind of data. So before doing transpose, we actually have to take this out. Use header row as a column, as a regular row, header row as a data row, so that states will also be in column, and when I do transpose they will the state codes will be in a row, and when I do transpose that row will convert into a column, because only rows will convert into columns, not headers. Okay, when I do transpose, that's when I earlier did transpose, all state codes disappeared. I want to have them. Yeah, so we have state code and year wise targets. Now is the time to make this as header. See why I did transpose. I did transpose because I wanted years here, not state codes. I wanted years. Now I'll go and select all the years. I'll go and select all the years and then do unpivot. You can do unpivot of selected columns, or you can do unpivot of columns that are not selected. So I'll click this. So this all gets unpivot. Now it is a tower. Now it is easy to use. We have state code and year wise targets, but I don't want previous year's targets because I don't need to show them anymore on my dashboard. So I have data only for current year. So let's filter this set. So when I filter this set, the underlying data will also get filtered. So for the reporting purposes, only the data which I select here will be available. It is completely filtered. Okay, so now I select 2006. Now I have data only for 2016. Now that I have latest data only for latest year, I don't need this column anymore. I can remove this column. Yeah, it is possible. So now I have state codes and then targets for that state codes, because my entire data is for current year. The two files that I got, they are for current year. So there's no need of maintaining that unnecessary data. So I can filter and I can ignore. This tool is very powerful. You can do lot many operations like that. Okay, now let's get back to the applications. And now here I don't want to have this as a separate table. The state funds, yeah, let's leave it as a separate table because we have more columns here. Okay, but this has only one column, values. So instead of maintaining this as a separate table, what I will do, I will merge this table into applications. I will merge that into applications. So how will I do? So we'll go to home tab, and here we have an option to merge queries. Merge the existing, which is applications, the master set. So to this I will merge state targets. On what? On state code here with the state code here. Remember the state code we extracted from this institution? Yeah, we are using that now. So we are joining these two, and the join that we selected will be left outer. So it will ensure that we will not miss any data from the master data set. So if there are no targets for any state code, then for those states it will show blank, but it will not ignore those states in our main data set, which is very safe. Okay, because we don't want to lose any data from the applications. If that's not the choice, you want only those states where there were targets, then go for inner join, only matching rows. Okay, fine. So safe option, left outer, select that. So that is added now. You have to select the field that you want. So what I want in this, I want just the value, not the entire table, just the value. Value is the target. I'll rename that column. This would be target. Okay, so we have a state-wise target appended here. We don't see all the data here. It's just a little preview. But yeah, believe me, that merge is appropriately calculated, applied. Okay, so yeah, so now we finished that. We have more options, like we can uh, choose certain columns that we want, and we can ignore columns that we don't want. We can like remove the columns that just we did in state targets. Keep rows, so we want to remove certain rows from top. So this is data cleaning. This is actual data cleaning. Yeah, data in some terminologies is called data massaging. So yeah, we can sort a column and then group by, and then we do all this stuff. Yeah, let's go. And so in transformation also we have a lot of transformation features, like replacing values. We want to replace it in certain value, we can do that. Pivot, unpivot, yeah, split columns, text operations. Then we have numeric operations. If there are any date, then we can extract time, day, date, week, all that. Yeah, date intelligence, we have that. We'll add column now. We'll explore this tab. We'll add a conditional column to this application table. So in this conditional column, so this is a UI for creating a conditional column. I'll name this as applications status. So what I'll do, I'll create three categories, like high, normal and low. High is for more number of applications, low and medium. Okay, so before that, let's check out. So in this I want to just check out uh, applications, total applications that are received here. So this field will give us total number of applications. Okay, total number of applications received from all states. So this I will split by institution ID, and I will see this as a table. So institution ID, actually this is not the correct, so this is institution name. Yeah, it's institution name. And let's check out the maximum number and minimum number. Okay, put this as a bar. or I can do better than this. So what I'll do, I will select by institution name, not by institution name. Minimum value, institution wise minimum value. Okay, let's just take the count of applications received in each institution and put a reference line. A reference line for average. I don't think we have an average line here. Okay, let's go for the line and then we put a average line. Average line add by count of applications. Okay, so we see this is the average line. Let's show data table for data label for that average line. So average number of applications received in each university across universities. Data label on. Okay. Yeah, so that's somewhere around 16.22. Yeah, so that's 16.22. So that's the average value. Okay, why I wanted that I will shortly tell you. Okay, let's take this out from here. Get back to the query editor. So now here I will create a new column, conditional column. So in conditional column, status, column name would be total number of applications. So the order of this conditions, is very important, because that's how this gets evaluated. This expression gets evaluated. Okay, so if it is less than or equal to we have total all races less than. If it is less than, say we just check this 20, right, is average, so I'll go and I'll put it as, if it is less than 20, slightly above than average, yeah, we will, it shouldn't be slightly above average. If it is less than 15, low, output should be low. I can actually type a text, or I can select a column. If I want to show any column, yeah, instead of a number I can show that, or I can simply type a value. Next rule, total applications, if it is less than 15. So if so how this gets evaluated, so we don't need to check between a range like 15 to 30 like that. So if a value is, when this calculation happens at a row level, if value is less than 15, then it will show as low. If not, then it will pass to the next statement. So in this next statement I will check if it is less than 50. If it is less than 50, yeah, so this is normal. Number of applications received is normal. Add another rule, if it is less, if it is not 50, if it is say greater than or equal to 50, after reaching here, if it is not below 15, it is not below 50, or I can say now I can put any upper limit here. I don't want to write again less than. I'll just say if it is 50 or more than 50, high. So yeah, that's why this order of evaluation is very important. You can actually move this order up or down, or you can take out a condition. Yeah, so options are there. This is a default option. If nothing gets passed, so you want to have on default values, yeah, we can put that here. Okay, so you see that new column has been added here. Okay, so you select, you can actually check syntax for this. When anything we do in Power Query, what happens actually, a Power M script gets generated. So these are script. So we added this additional column, right? This can also be added like this using the function each if. Each if is a function. So each if, then else if. So it has similar syntax to other programming languages. Then last is else null. If nothing is specified in otherwise condition, right? So that's why null. So this is a M syntax. So we just added, so here it will show the last operation. We just added the conditional column here. Okay, we have other columns, like most of the times we may want to have one unique identifier for each row. If there are any duplicates, we want to generate a unique identifier. That is nothing but an index column. Index, you can start it from 0 or we can start it from 0 or 1 or any value that we want, and a unique key will be generated for each row. Sometimes it will be very handy. Yeah, and if you want to write a more composite column, custom column, then we can go and write it in M. Using M we can create more complex column, like a date functions. We want to extract days and then add it to another field, compose a new date out of it. Any expression we can write here and compose custom columns. So these are the transformations that we did. Let's check out, did we, yeah, so yeah, most of the transformations we covered. Summary tables, yeah, let's do the summary tables. So now I have this data, so I want to create a summary table. Like I want to store applications received, actual application received by institution name. Yeah, by institution name, the number of applications received. So I can do that group by. So if I do group by, this existing table will get modified. Yeah, this existing table gets modified. But that's not what I want to do. So what I have to do, see, let's first do that here once. Okay, group by. So I can do group by institution ID. No, by I want to do by institution name. Institution name, what I want to do, I want to do count of rows. Yeah, this is what exactly I want to see. How many applications received per institution. Okay. No need to select any column here because we are counting rows. So what happens, this existing table gets transformed and a new aggregation table will be placed. See, this entire thing has been replaced. So these are the universities, and those are the number of applications received. So there is a new table that got created, but actually this is the existing table got transformed like this. Maybe this is not how I want to do. So what I will do, I will create a duplicate copy of this table. Applications, right click. We have some options here as well. Right click on the table, you get some options. Say duplicate. So this application table gets duplicated. Now this, give a name, applications aggregation. It's still loading. Okay, here it is. I got it. So on this table I will do aggregation. So before doing that, I don't want to have all this operations, so like adding that conditional column, capitalizing, renaming columns. Yeah, change split columns, yes, leave it till there. Actually I don't need split columns also. Split by deliver, append query, yes, keep data up to here. On top of this, now go and compose aggregation. Yeah, so this is still referring to this data set. Now on this I'll do group by institution ID, no, not institution ID, institution name. Okay, so this is an aggregation table which is part of our data model. Now we can make aggregation tables like this. So we have covered most of the transformations that are available in query editor. So I got back to Power BI desktop. I exited from Power Query.